In this video, we're going to have some examples of how to use special right triangles. It can be a little tricky at times, although she'll show you some of the special tricks to help make it easier. So here's an example. Example number 1. We've got a right triangle. We notice that we have base angles that are congruent, so therefore this is a 45-45 90-degree right triangle. We see that one of the legs is 8. And we know that in a 45-45 90-degree triangle, the hypotenuse is always the leg times root 2. So it's 8 root 2. Therefore, x equals 8 root 2. And we're done with that problem. For problem number 2, we have a right triangle, and we notice that we have two sides, which are the legs, that are equal in measure, since the legs are congruent, and it's a 45-45 90-degree triangle. The legs are x, and so the hypotenuse would be the leg x times root 2. But we're given in this picture that that hypotenuse is 5. So that means that 5 is equal to x root 2. We can divide both sides by the square root of 2 to solve for x, and we get that x equals 5 over the square root of 2. But there's a problem with this, and this is something called rationalizing a denominator. We never leave square roots in denominators. It's bad form. And we note that if we ever multiply a square root times itself, so the square root of 3 times the square root of 3 will equal 3. It gets rid of the square root in a way. Then we have the square root of 2 times the square root of 2 equals 2. The square root of 5 times the square root of 5 would equal 5. So if we have a fraction, something like 3 over the square root of 2, if we multiply it by square root of 2 over square root of 2, meaning a fancy 1, we will rationalize the denominator. We'll end up with 3 root 2 over 2. Now the denominator is no longer a radical, and so it is called rationalizing the denominator. If we have 7 over the square root of 3, we could multiply that by the root 3 over root 3, and we end up with 7 root 3 over 3. If we had 6 over the square root of 2, we could multiply that by the square root of 2 over the square root of 2, which would give us 6 root 2 over 2. But 6 can be divided by 2. And so when we do that, we have 6 divided by 2, we end up with 3 and then the square root of 2. To rationalize a denominator, the square root is not a rational number. And so we want to make sure that our denominator is a rational number. And that's why we're getting rid of that square root down there. Now let's go back over to the left-hand side where we were in the middle of, or almost near the end actually, of example number 2. We have x equals 5 over root 2. Well, from our discussion over here on the sidebar, we realized that if we just multiply that by root 2 over 2, we will rationalize the denominator, and the answer of x equals 5 root 2 over 2 is achieved, which is the final answer. In our third example, we have another right triangle, and we can see that we have one of the acute angles is 45 degrees, so we know that both of the acute angles would be 45, and it's a 45-45 90-degree triangle. And we know that, again, the hypotenuse is a leg times the square root of 2. In this case, the leg is 7 root 3. So the hypotenuse, x, is going to equal 7 root 3 times root 2. Well, we just multiply the two square roots together, and we end up with 7 root 6. So that's the final answer, x equals 7 root 6. Let's now move on and look at some examples. And this time we've got a 30-60 90-degree triangle. And we know that in the 30-60 90-degree triangle, the hypotenuse is twice the short side. So we need to recognize where's the short side. And the short side is opposite the smallest angle. We learned about that with triangle inequalities. So that opposite 30 degrees, we've got it marked in blue here, that x is the short side. And that short side would be half of the hypotenuse. Since the hypotenuse is twice the short side would be half the hypotenuse. So therefore, x is equal to 11. Now the third side, which we have marked as y, is going to be opposite the 60 degrees. So we've got that our third side is opposite 60 degrees, and we know that the third side is the short side times root 3. Since we just found out that the short side is 11, we know that y will be 11 root 3. In our fifth example, we have once again a 30, 60, 90 degree right triangle. And we're going to recognize where's the short side. Well, the short side is x because that's opposite the 30. The third side would be 15, which is opposite the 60 degree. And the hypotenuse is the y. So in this we can say, well, I've got the third side there, so I'm going to talk about it. And the third side is always equal to the short side, root 3. So I'm going to plug in what I know. Well, I know that the third side is 15, and I know that the short side is x, so I end up with an equation, 15 equals x times root 3. Dividing both sides by the square root of 3, I end up with x equals 15 over root 3. This is like that problem earlier. I need to rationalize the denominator. Since I've got the square root of 3 in the denominator, I multiply by root 3 over root 3. And I end up with 15 root 3 over 3. But 15 can be divided by 3. So I end up with 5 root 3 equals x. And that's great. Now I've solved for the short side. We're not done with this problem because we had to solve for both x and y. So now that we have the short side, we remind ourselves the hypotenuse is twice the short side. So that y, the hypotenuse, equals 2 times the short side, 5 root 3. Well, 2 times 5 root 3 is 10 root 3. And that's the last of the examples. So I hope this will help you with doing some of your problems with the special right triangles.